I'm going to work through the problems on the practice final exam for Math 1113, but I wanted to let you know before I actually started in on the problems that for the final exam, you are not proctored, which means you are able to use your notes and your resources. Also, it only covers the second half of the course, so that's units 4, 5, 6, 7, and 8. Also, if you navigate to the content under the final exam, you'll see a formula sheet. So on this formula sheet, as well as at the beginning of the practice exam, you'll see all of the various formulas that you'll have access to during the exam, including your trigonometric functions, your double angle, your power reducing, and so forth. So those will be available at the beginning of the test. You will want to probably have some scratch paper. You'll want to have a calculator, and then have that formula sheet either printed off or at least know how to access it, and have your notes organized so you can go to that particular topic relatively easily. The test is entirely multiple choice and for the actual final exam. And I don't recall right off the bat how many questions are. I'll try to look that up for you guys. But this is the practice exam, and I want to kind of work through the problems. So number 1 says, find the natural log of 2.1 and round to 2 decimal places. Well, guys, that's basically a calculator problem, and that comes from Unit 4 on exponential and logarithmic functions. So if I pull up my calculator, I would type in ln of 2.1 and enter, and we get 0.7419. So we get this number here. Okay, so in the calculator we get 0.7419, and I'll write it all out for you. 37373447. Okay, 47. So you have this big long decimal. Be careful, the instructions ask you to round it to 2 decimal places. So if I think about rounding this big long decimal to 2 decimal places, okay, I notice that in the second decimal place is 4. Next to it is a 1, so I'm not going to change anything. So rounded to 2 places, my answer is 0.74. Okay, question 2 says Cora is saving her son's college education. If the savings account earns 2.8% interest compounded monthly, and she wants to have $25,000 in 18 years, what must the principal or the initial amount be? Round your answer to the nearest dollar. Okay, so again, this is a question that comes from Unit 4. It's related to logarithmic and exponential functions. It's an application of the interest, and we're told it is compounded monthly. So my formula is A equals P times 1 plus R divided by N raised to the NT power. A is your final amount. P is the principal. How much money did you start with? R is the interest rate, which typically is stated as a percentage, but when we do the calculation, we use it in decimal form. N is the number of compoundings. How many times do we calculate the interest? Typically, that's going to be a word that ends in "ly," like monthly, daily, weekly, quarterly, and then T is the time, and time is usually expressed in terms of years. So I would go through my problem and read through it a second time and identify this information. It says if the savings account earns 2.8%, so R is 2.8%. Change that to a decimal, you divide by 100, it's going to be 0.028. Compounded monthly. Monthly means each month, so that's 12 times in a year. If she wants to have $25,000, so my final amount is $25,000 in 18 years, what would the principal amount be? How much money would she have to start with? And then ask you to round that to the nearest whole. So once I've identified all of the pieces, all of my information, then I'm going to substitute that into my formula. Okay, so I would have 25,000 equals the principal I don't know, 1 plus 0.028 divided by 12 raised to the 12 times 18 power. And then you need your calculator. Okay, so, and I kind of work from the inside of the parentheses out. Okay, so if I were working this problem, I would start inside the parentheses. I would have 25,000 equals P times 1 plus, and I'm going to do that division. So I would have 0.028 divided by 12 equals, and we get 0.0023 repeating. So we have 0.00233333 raised to the 12 times 18 power. Then I'm going to add 1. Again, continuing to work inside the parentheses. I would have 25,000 equals P times 1 plus that is 1.00233333 raised to the 12 times 18 power. So again, I'm going to do that on my calculator. So I'm going to say plus 1. That gives me that answer. Then I've got to take that answer and raise it to 12 times 18. And notice I put parentheses around that exponent. Okay, so I raised that to that power. So when we do that, we get 25,000 equals P times 1.653457826. 7826. Okay, remember I'm trying to solve for P. So then to solve for P, I'm going to divide both sides by that value. You want to carry the decimals with you till you get to the very end. Okay, so again, putting that into my calculator, I'm going to end up with P equals, and the way I type it in my calculator, I'm going to put 25,000 divided by that lovely answer, and I get 15,111.6. Okay, since you have 0.6 and you're to round to the nearest whole, that means we should do $15,112. All right, the next question says, which of the following is the graph of log base 5 of x? Okay, so again, this comes from Unit 4, dealing with exponential and logarithmics, and you're looking for this logarithmic equation. So a couple of things you can do. I would probably try to graph it on my calculator, which you should be able to do. If you go to y equals, let me clear this one out, and then I'm going to go to math and arrow down. I believe this is where it's located. I need log with a base, so I'm going to choose this option, and I'm going to tell it base 5 of the variable, and then I'm going to graph. Okay, so I get this graph, and if I want to look, I can look at a table of values to kind of help me out. Okay, so I have an x-intercept at 1, 0, and I also have a point at 5, 1. And we can see the graph. So looking at these that we have on our paper, I can rule out the second one, okay, because it doesn't look like the one on my calculator. It could be none of these. The fourth one doesn't look like the one on my calculator screen, and neither does the fifth one. So I've ruled out, based on the graph on my calculator, I've ruled out 3 of the 5 choices. So it could be none of these, or it could be this first one. Well, I noticed that this first one does have the y-intercept at 1, 0, and it does have a point at 5, 1, which seems to match the other one. So I would say that this first graph is the correct answer. Again, try to use process of elimination. Use your resources, use the calculator to create the graph. Then as we move to question 4, we get into module 5, which begins the introduction to trigonometry and the right triangle. So question 4 says, given the right triangle below, find the tangent of theta. So on your formula sheet, it gives you the relationships for a right triangle. Tangent, if you'll remember, is the opposite over the adjacent. So focusing on where theta is located, opposite, adjacent, and hypotenuse. So I would have my opposite value is 3, my adjacent value is 4, so my answer is positive 3/4. Then question 5 says find the angle in radians between 0 and 360, which intersects the unit circle at the point -√3/2 and -1/2. Now, it's important for you to notice that there is a unit circle on the formula sheet. I've copied one onto the page here, and we're looking for -√3, -1/2. Now that may help you to realize, okay, this has a negative value and a negative value. And when you have a negative x, negative y, you are in quadrant 3. So I want to I know that I need to look in quadrant 3. Okay, so looking at my unit circle, you have quadrant 1, quadrant 2, quadrant 3. And I'm looking for the ordered pair -√3/2, 1/2, which corresponds to this point here, which is 210 degrees. Okay, so the angle in degrees between 0 and 360, where the circle intersects -√3/2, 1/2, is at 210 degrees. Okay, number 6 asks you what is the phase shift of the following function, and you're given y equals the sine of x plus 7 pi 6 plus 3. Okay, phase shift is the term used to represent a horizontal translation. So you're either going to go left or right. And that particular piece is determined by the expression in the parentheses. It's usually in the form y equals a sine bx minus c plus d. Okay, so you have to do the opposite of this sign. So since it's plus and we would normally go right, we're going to do the opposite and go left 7 pi 6. My phase shift is left pi 6. Now another thing you can do there if you want to kind of avoid making an error with the sign is to take this expression x plus 7 pi 6 and solve it for 0. And when you do that, you get x equals negative 7 pi 6. So it's a little bit more obvious in that case that it's negative and you need to go left. As a side note, just to kind of help you as you're thinking about preparing for the final exam, this number here at the end, that's tagged at the end, the plus 3, corresponds to a vertical translation. And so that's going to tell me whether to go up or down. Positive would go up. So in this case, we would have a vertical translation and move the graph up 3 units. Question 7 asks you which of these graphs or which of these shows the graph of cosine of x plus pi 4 minus 2. So you need to be familiar with your transformations in order to make that decision. Again, I have this minus 2, so that tells me that my graph of cosine is going to be shifted down 2 units. And I also know that it's going to be shifted left pi 4. I also know that cosine normally starts at 0, 1 and then ends at 2 pi 1. Okay, so that's kind of the basic shape of a cosine. So the first option is none of these, and it could be that. So if I look here, let's see, normally we would begin at 1. And if we shift up 2, we would be at 3. And then we got to shift back to pi 4. Okay, notice your scale, you're between 0 and pi halves. So this is a maybe. Okay, this curve, when I look at this curve, it doesn't look like a cosine curve. Okay, or if it is a cosine curve, it looks like it's been flipped over because it's starting down instead of starting up. Okay, so I don't think it's this one. This one has been shifted down 2, but we know it should be up 2, so it's not that one. And then we got one more. And gosh, this one looks like it's been flipped around, but it also looks like it's been flipped down, so it's not that one. So we're down to none of these or the second one. So again, if I look at this, I'm between 0 and negative pi halves, halfway I would be at 3. And then if I do a full cycle, I'm going to end at 3 because we shifted it up 2. Here's my 0 line. So it's this one. Now again, you could put that into your calculator. You would need to convert your window. I can tell it to zoom and do the trig, which is 7. and then I can enter it. I would enter the cosine of x plus, and I'm going to put the pi fourths in parentheses, second pi divide 4 plus 2. Okay, and then I'm going to graph. Okay, so it kind of gives you some points to look for. Okay, that might help you. You can look at the table and see kind of where you should have points. Okay. All right, let's move on. Number 8 says, which of the following, and it's a multiple choice question, is equivalent to 1 minus cosine squared x divided by cosine squared x for the defined values of x. So this is one of those that comes from Unit 6, I believe, where you are trying to simplify this equation using your trigonometric identities. Okay, so one of the things that strikes me right away is this top is a difference. But I know if I think about my Pythagorean identities, I know that sine squared x is 1 minus cosine squared x. That's one of my Pythagorean identities. Now that may not jump out as you as quickly, but remember, we oftentimes want to take something that's being added together or subtracted and rewrite it in terms of a single function. So I can replace the numerator with sine squared. So I have sine squared x over cosine squared x. Then if I apply the quotient identity, I know that sine divided by cosine is tangent. So this would be tangent squared x. This would be my answer. Okay, you're just manipulating it, simplifying it. And again, I talked earlier in one of the other videos that the point of simplifying that is, especially when you get to trigonometry, having that one single trigonometric function is going to be a lot easier to deal with than if you have that fraction looking thing with a sum and other trig functions. Okay, so then number 9 is, it says, given that cosine A is negative 4/5 with angle A in quadrant 2 and sine B is negative 24/25 with angle B in quadrant 3, find cosine of A plus B. Okay, so this one's asking you to find the sum of the two angles A plus B. That is one of the formulas that's given on your formula sheet. That's a sum and difference formula, okay, here on the left column. So we want to write down our formula, okay. So we would have cosine A times cosine B minus sine A sine B. But this is really a three-step problem, and we've talked about that before, because you know cosine A is given, you know sine B is given in the problem, but I need cosine B and sine A. So step 1, I'm going to find sine A, and I'm going to use the Pythagorean identity to do that. Cosine squared A plus sine squared A equals 1. And I'm going to do the substitution. So I would have cosine A is negative 4/5. So I have negative 4/5 squared plus sine squared A is 1. So I have 16/25 plus sine squared A equals 1 whole. And I'm going to write that as 25/25. Okay, then I need to subtract 16/25 from either side, which gives me sine squared A equals 9/25. I don't want sine squared, I just want plain old everyday sine. So I'm going to square root both sides, noting it could be positive or negative. So I have sine of A equals 3/5. We were told in the original problem that A is in quadrant 2. So if you think about your coordinate grid and you're in quadrant 2, your your cosine is negative and your sine is positive. So we need the positive 3/5. So here's sine A. Then I go back and I start over, and I've got to find cosine of B. Again, I'm going to apply the Pythagorean identity. So I'm still going to use cosine squared B plus sine squared B equals 1. Okay, so cosine was given to me, or excuse me, sine was given as negative 24/25. So I'm looking for cosine squared B plus negative 24/25, and that equals 1 whole. So we have cosine squared B equals, or excuse me, plus 25 squared is 625. 24 squared, which you can do on your calculator, is 576, and that equals 1 whole, which is 625 over 625. I'm going to subtract 576 over 625 from either side. Okay, let me see if I can get some more space here. Okay, so we have cosine squared B equals 625 minus 576 is 49. So I got 49 over 625. I don't want the square, I just need plain old cosine. So I'm going to square root both sides. Again, realizing it could be positive or negative. So I have cosine of B equals 7/25. We are originally told that cosine or angle B is in quadrant 3. In quadrant 3, you would have a negative cosine and a negative sine. So I need negative 7/25. So there's cosine B. So now I have all of the pieces, and I've got to put them together into that formula for cosine of A plus B. So again, cosine of A plus B is cosine A times cosine B minus sine A times sine B. And we're going to plug and chug into that particular formula. So cosine A, make sure I get the right numbers, cosine A was negative 4/5. Cosine B was negative 7/25. Minus the sine of A was 3/5 times the sine of B, which is negative 24/25. And I'm going to do the math. So I have negative times a negative is a positive. 7 times 4 is 28. 5 times 25 is 125. Minus and a minus are going to make a plus. 3 times 24 is 72 over 125. I have a common denominator, so I keep the denominator of 125. 28 plus 72 is 100. So I have 100 over 125. I need to simplify that fraction, and it becomes 4 over 5. So your answer, cosine of A plus B, is positive 4/5. Okay, a lot of that is just basically number manipulation, plugging and chugging, but it takes time and you need to be careful and watch your signs. Okay, number 11 says determine the values for theta in radians of the equation below. And so you're asked to solve the equation 4 sine squared theta minus 9 equals -7. So I'm going to isolate sine squared. I'm going to add 9 to either side. So I have 4 sine squared theta equals +2. I'm going to divide both sides by 4. So sine squared theta is 2/4 or 1/2. I'm then going to take the square root, realizing it could be positive or negative. So I have sine of theta equals plus or minus 1 over the square root of 2. Now, if you remember from your algebra days, you cannot leave that square root of 2 in the denominator. So I've got to do a little bit of work. I'd have 1 over square root 2. I'm going to multiply the numerator and the denominator by square root 2. So I have square root 2 over square root 4, which is square root 2 over 2. So this becomes the sine of theta is positive or negative square root 2 over 2. So I'm asking myself, where on the unit circle does the sine equal square root 2 over 2? And it can be positive or negative. So remember on the unit circle that the sine of the angle corresponds to the y coordinate. So if I look at my unit circle, wherever my y coordinate is square root 2 over 2, positive or negative, that's going to be my answers. So theta is pi fourths, 3 pi fourths, 5 pi fourths, and 7 pi fourths. You have 4 different answers because it could be positive or negative. Okay, question 12 says, given the triangle ABC with the measure of angle C at 115 degrees, side A is 6 and side B is 8, find the area of the triangle. Okay, so because you have this angle of 115 degrees, this is what we call an oblique triangle. And there were 2 formulas that we learned about that are related to an oblique triangle. It does not specifically tell us here, to use Heron's formula, so I would use the formula for my oblique triangle, which doesn't appear to be on the formula sheet, but I believe, let's look. If we look at the practice, got to preview it so you can see it. Okay, on the formula sheet here, let's see if it has, yes, area of an oblique triangle. is 1/2 BC sine A or the other numbers. So since we have angle C, we have the area is 1/2 AB times the sine of angle C. Let me make sure I wrote it down right. Okay, yep, AB sine C. Okay, and we're given everything. So it's a plug and chug, guys. So you have the area equals 1/2 times side A, which is 6, times side B, which is 8, times the sine of angle C, which is 115 degrees. So if I do this, half of 6 is 3. 3 times 8 is 24. So I have 24 times the sine of 115 degrees. And it wants one decimal place. Now, when I go out to use my calculator, guys, you have to be careful and make sure that your calculator is in degree mode. So I press the button that says mode, and I can see that the word degree is highlighted. So I would simply type 24 times the sine of 115 degrees, and I get 21.75. Rounding to one decimal place, that's going to be 21.8. So the area of that oblique triangle is 21.8 units squared. All right, we're down to question 13. 13 says, given the right triangle below, find the sine of theta. This goes back to the definitions of a right triangle. If you remember, the sine of theta is the opposite over the hypotenuse. Okay, so you have to pay attention to where angle theta is located. You have opposite, adjacent, and hypotenuse. So opposite is 3, hypotenuse is 5. So the sine of theta is 3/5. Guys, some of them are that simple. Don't overthink it. Question 14 says, find the angle in degrees between 0 and 360, which intersects the unit circle at the point positive square root 3 over 2, positive 1/2. So I see that I have a positive x and a positive y. And when I have a positive x and a positive y, I know that I'm in quadrant 1. So I just need to find the right ordered pair. Square root 3 over 2, comma 1/2 corresponds to a 30-degree angle. It wants it in degrees between 0 and 360. Again, remember, you're given the unit circle as part of your formula sheet. 15, we're back to looking at graphs again. This one is negative 1/3, which changes the amplitude. Normally, the amplitude kind of corresponds to your height. Okay, how tall it is. Normally it is 1, but in this case, we have shortened it to 1/3. And the fact that it's negative tells me that we're going to reflect on or over the x-axis. It also is not going to take us as long to see the full picture because of this 4. That causes a horizontal shrink, or it basically squeezes it together. So normally it would take 2 pi to see this full graph. It's only going to take us pi halves. And again, you could try to look at it in your graphing calculator. We could type that in. We could have y equals, clear this one out, I would have parentheses, -1 divide 3, close them, sine of 4 times x, close it. And I want a graph, and you get kind of this zigzaggy pattern. Okay, so if we go back and we look at these, okay, it should be more of a curve instead of a zigzag. So let's think about this. If we look at our options, one of them jumps out at me right away that is probably not right, and or a couple of them. This one, because it's too tall, okay, this has got a height of 4, and so that's too tall, and this one is too tall. Okay, so let's look at these others and see what we think. Okay, so normally sine would start at 0 and end at 0, and it's turned upside down. So this is a possibility. Okay, let's see. This one, it starts at 1 or -1/3. This is the cosine curve, so it's not this one. This is actually the sine curve, but it's not reflected. It doesn't take into consideration the fact that it's negative, so it's not this one. We already eliminated the one that was really tall. This one again starts at 1/3 instead of at 0. This is actually the cosine curve, so it's not this one. So by process of elimination, or again, you can match it to what you see on your calculator screen, it's the first one. And then the last question says, for negative pi, including negative pi, to pi, not included, in radians, find the equation, the solutions for this equation. So you have 3 times tangent squared theta equals 3 tangent squared theta. So the first thing I'm going to do is get these things on the same side of the equal sign. So I'm going to have 3 tangent squared theta minus 3 tangent theta. Then I notice equal to 0. I have a common factor of 3 and tangent, which leaves me with tangent theta minus 1. That equals 0. So then I know that either tangent of theta is 0 or the tangent of theta minus 1 is 0. If I solve that for tangent, I have tangent of theta equals 1. Now remember, it's not as easy to identify tangent from the unit circle because it's not a direct read. You have to kind of be familiar with how it is laid out. So for tangent, it's normally sine over cosine, and for it to be equal to 0, your sine value would have to be 0. So if I look at my unit circle, my sine is 0 at 0 and at pi. Now here's where you have to be careful, okay, because you want between negative pi and pi. So it could be 0 or it could be negative pi. Negative pi would indicate that you rotated negatively. It cannot be positive pi because, see, that's not part of your options up here. The positive pi is not included. Then for the second piece, you want to consider where is the tangent 1. Well, to be 1, you have to have the same value for sine and cosine. So that occurs here where you have square root 2 over square root 2, and you want it to be positive. So a positive divided by positive is a positive, so it could be pi fourths. Over here in the second quadrant, you have a negative divided by a positive. That's not positive. Third quadrant, you have a negative divided by a negative, which does work. But again, you got to be careful because 5 pi fourths doesn't fit in the interval. So we have theta could be pi fourths, or when you rotate negatively, this would be negative 3 pi fourths. Okay, you got to be careful. You got to stay within the limitations that are provided with the problem.